Welcome. In this video I'm going to show you how you can create bins using R. I'm using Jupyter Lab with a R kernel, but this should also work in RStudio, for example. I have currently R version 4.3 installed, probably should be updating that sometime soon now, and only have loaded the basic packages that come once you load R. This video will focus on how to simply get the bins, how to determine the number of bins that you need. I have a separate video and also a whole documentation about that. This is simply about how can I actually get those bins. To show you how that can be done, I need some example data. So I'll be loading in the general social survey data from 2012, adjusted for some example purposes. The field of interest is actually age in there, so I'm going to remove the missing values. And there's one that's 89 or older, so I'm going to replace that simply with 89. And it's just an example, and make sure everything is numeric. So now I have some numbers, and then I can actually show you how you can use the cut function that actually does that for you. The cut function, you feed it the scores, and then you say, for example, I want 7 breaks. So then it will actually create, it will convert each score into a category. And if you then run table on those cuts, you actually get to see which categories it's made and also how many were actually in there. If you just run cuts, you get like these bins multiple times. Note that it's using these round brackets or parentheses to indicate that it's excluded, and square brackets if it's included. So this would mean the 17.9 itself wouldn't fit into this bin, and the 28.1 would actually fit in because that one is included. Now that's the default, that it includes the upper bound, but it excludes the lower bound. If you want that the other way around, we can actually first also check if any values were missing, but in this case there's only false, so that means all cases were actually in a bin. We can change the default by setting right equals false. If we do that, then it would actually go the other way around. As you can see now, what it's done is it's including the lower bound and excluding the upper bound. And again, there are no missing values. As you can see, it's using 89.1, and 89 was actually the maximum. So note, this should be note, note that the number of bins you're actually giving it is just a suggestion. It will attempt to use nice values for the bin limits, but it might actually change it. If you want to use exactly your own bins, then you can set the breakpoint. So for example, I can set the minimum score and the maximum score, and I want a sequence of 7. And then actually use those as my breaks. So perhaps show you what those breaks then actually are. So if I do it like in this, I can actually show you the my breaks. So then you can see what the breaks are. So it's going to break at 18, but under 29.83, 29.83, and 41.66, etc., all the way up to 89. If I use that, I already made the break, so I don't need to do that again. If I use those as breaks and use right equals false, then there will be some missing values because now the 89 is not included, and though there were actually 15 who should have been in that last one then, or actually perhaps this last one should have been up to 90. You can actually use also include lowest to use this. It's a bit odd because as soon as you put right equals false, this acts more like include highest. So here I'm setting right equals false, so it would be similar as the one above here. But now I'm saying include lowest, which means that for the last category, it will actually also include the upper bound. So if I run this one, I shouldn't have any missing values anymore. As you can see, they're all false, so no missing. And as you can see, everything else stayed the same as the one above. So almost everything is the same, except that last one. Here, the upper bound was excluded, and here it gets included. Of course, you can flip this around. You can use right equals true and then set include lowest is false. Then it will actually apply to the first bin that you have. So now it's not including the lowest one. And if you actually set include lowest is true, then it will include also the lower bound of the first bin. Alright, I hope this gave you an indication of how you can work with bins, or create them at least in R, and I hope this video was helpful. Thank you for watching.